Bring your bar graphs from what I think you did in elementary school, right?
Yeah.
Which class period has the least amount of students? Got 7, right? Great. Letter B, approximately how many students are in Mr. Jones's 6th period class? Foz. Take anywhere from 21 to 22, because you're in between 2 labeled intervals, all right? See, how many class periods have between 25 and 30 students? Still. Which classes are those?
1 and 2.
Yes. All good? All right, this is called a double bar graph, and they're color coded based on male versus female, or men versus women. Which movie categories are more popular with men? Cat. And what else? There's 2 of them.
And 4. There's 3.
Yeah, there's actually 3. There's 2 more.
How many?
Take a look at your color. Light gray, I know maybe doesn't show up as well on the smartboard as it does in your booklets. But your light gray is your men, so you have your action. What else, Kat?
iPod.
Correct. And there is one other.
And 4.
And horror, yes. Great. Which movie categories had between 5 and 10 women? Correct. Correct.
What is sci-fi?
Science fiction. And finally, approximately how many more women than men for drama movies? Try to be exact. Try to be. I think you can do exact. Luke?
I said about 20, but really like 18.
I got 18. Because I got, look, if you look at, what is it again? It's drama movies, right? So if you go to your drama, it's definitely 30 for men, because it's right on the line. I'm sorry, for women. And you got to say that that's 12 because it's slightly below, halfway between 10 and 15. So 30 take away 12 is 18. I mean, if you had a quiz and you put 17 or 19, I would still give you credit. But 18 is really what you should get. All right, so let me just kind of give you the explanation of what a histogram is. It's like a dot plot. The only difference now is rather than plotting exact values, you are plotting ranges of values. So if you fit into a certain category, let me give you a for instance. Everybody's got a unique height in inches, right? Maybe there's 2 that are exactly the same height. But let's say if I did everybody in millimeters, it's highly unlikely that all of you are, or there's more than one of you that is exactly the same height millimeter-wise. If I were to really, be very strict about how I measured you up. So everybody's got a unique millimeter height. And if I had to make a dot plot, how many dots would I have on my dot plot? I mean, how many students do we have in here? I don't even know. But approximately how many dots would you have? 25 if they're all here today. I think I have 29 in this class, actually. But not everybody's here. How many we got? Figure, whatever, but you get the idea. So I would have approximately 29 dots if I plotted you everybody individually. Okay? And there may be only 1 dot, because not everybody's going to be exact. But what if now I take my dot plot and saying exactly, I don't know, give me a reasonable, plausible amount of millimeters. I got to do a quick little...
80 or 8 centimeters.
That's true. That is true. Well, you give it to me quick. Give me reasonable. You know what? Let's do this. Let's do centimeters. It's easier. A meter is 100 centimeters. That's fine. Okay. So let's say if I did it by centimeters, but instead of doing it by centimeters, I put you in ranges. I want to know how many students are between, let's say, 100 and 110. Now it's more than one that could fit into that range. And my next set of values is 110 to,
120.
what am I counting by?
10.
By 10, so 120, okay? 122, and then 132. And obviously, my ranges have to cover my lowest low and my highest high in the class. But it takes those data values, and instead of making them unique data, it puts you into a range. That's what a histogram is. In lesson 4, it's not a difficult lesson, but there are certain little procedures that you have to do in order to accurately put everything where it belongs. It's a lengthy lesson. It's one of the longer ones that we do. Well, it's not that we have that much left to do, but this one and lesson 5 are both pretty long. We're going to need 3 lesson blocks to probably get through everything, and maybe even 4. And then we have only one more other lesson, and we'll test the end of next week, and then we can review for the final. Okay, so let's do this together. If I get you through 2 examples, then you'll probably be able to do at least through page 10 all by yourselves today. Let's see how we go. I do need you to read this first example quietly to yourself so you get an idea of what it is they're asking you to do. Take some time right now and read that quietly to yourself. Okay, what do you have to do, or what do the students have to do? John?
They have to get their head and measure the circumference of their head.
Do you know what circumference is?
Like how big your head is.
Yeah, the distance around your melon. So you have to take a tape measure,
Yeah, this one.
and you have to wrap the tape measure around your head, and record whatever the millimeters are, and then based on that, the students have to order hat sizes based on these ranges. And so now if you go to the frequency table, the extra small range or circumference size is anywhere between 510 and what does this symbol mean? Less than. So it's 510 all the way to 530, but not including 530. So technically, 510 to 529. And then the next interval starts at your 530 and goes to 549 technically. But this is the way they express it by showing this less than. So what we have to do is take the actual sizes of the students and tally them in the appropriate category by hat size. And you're going to go through the same process as you did when you did your dot plots. What's good about this, do you notice why this is going to be a little bit easier? What makes this a little bit easier than having to do what we did with the dot plots? It's the way it's arranged.
It's in numerical order.
It is. So they start with the lowest, 513, and they progress upwards. So that makes it easier so you're not jumping around everywhere. But you still have to be careful because every time you do a tally, you got to cross it off the list. Okay, so I'll do the first one for you, and then the rest you can do, and then we'll verify and see if everybody got our frequency counts correct. So I take my 513, and that's in my extra small size of 510 to 530. Make a tally mark. And then 525 is in that same span. But that's it for that. Now that 531 is in my next row. And so is 533, 535, another 535, 542, 543, 546, and 549. That takes care of that. All right. Do the rest, and we'll compare and see if we got it all right. All right, let's verify together. I got 2 for extra small, that together, and then 8, 15, 9, 4, and 2. What should it add up to? And they don't tell you in the introduction how many values there are, but you really should go back and count all the values in the box and make sure it matches up. It should add up to 40. I want you guys, when we do the histograms, you'll see this will lead into lesson 5. Every time you do your frequencies, at the bottom somewhere, put the total. As you see, when we get into lesson 5, you're going to need that. Okay, so there's 40 total. And it's a good verification too, because you want to make sure that there's 40 values This adds up to 40 because there's 40 values in the box. Okay. So now based on the tallies, what is, if someone had a head circumference of 570, I'm just going to the bottom part B. If someone had a head circumference of 570, what size hat would they need? Just see if we could, yeah, go ahead, Kurt. It would be a large, right? Okay, got it? Next page. What hat size does the data center around? And I want you to pick one interval for me, please, or one hat size. Most popular in this case, medium. What are some of the patterns that you see in the hat sizes? Let's take a look. Jack Trice.
The largest and the smallest don't get as many as the rest.
Okay, so you could say at the tail ends that has the least frequency, right? I would agree with that. Anything else you could say? The middle has the most, yep. It clumps around the middle. Okay.
More big heads.
Say that again?
More big heads.
Well, that would imply that the center of the data would be around extra large to extra large, but it's not. Okay. Is it fair to say that the hat sizes or the head sizes go up and then down?
Yeah.
All right. So they kind of, and then they peak at medium and then they go back down again. So all of it's valid observations. So I'm going to put what we have here. Starting at the smallest, it goes up. It peaks at the medium, and then the frequency drops down again. So frequency increases and then peaks at medium, and then from medium all the way to double XL, it starts to go down. If you take a look at the frequency table again, imagine I would take this whole thing and I turn it on its side. Wouldn't it look like kind of like a bar graph? Think about it. These tallies, doesn't it kind of look like a bar graph turned on its side? That's what a histogram really is, because from here you're going to really make a bar graph based on these ranges. Okay? Because that's really what a histogram is. It's a bar graph. It's a tally. It's like a tally count turned on its side. So I'm going to show you how to construct one and make one. They're not difficult to make, but you got to be careful of some certain things. Let me go back. Let me review the steps on how to make these things, and then you actually just learn by doing them. When we make one, we're going to draw a horizontal line and mark the intervals. The intervals are like your little number spans. Like in this case, when we did it, you had 510 to 530, 530 to 550. So those are called our intervals. Finding and choosing the right interval is the hardest part. You'll see, because sometimes it's better to count by 5s, sometimes it's better to count by 10s, sometimes even more than that, depending on how widespread or variable the data is. The vertical line, the one that goes up and down, is always the frequency. Those are your actual counts. So this here, your horizontal line, is going to be where your intervals are going to be. You don't have to write this, just kind of take a look where you put your spans. And then the actual counts, the tallies, is your frequency. Mark the frequency axis with a 0, and it goes up to something that is greater than the largest frequency in the frequency table. So let me ask you this. Go back to that frequency table. What was our largest value?
15. 630.
Be careful, not the interval. The counts.
15.
15. So when we make it, you need something that's going to start at 0 and go all, even though you have no zeros, and go all the way to 15. A lot of the times you count by 1s. Sometimes, if it's really a lot, you have to count by 5s, maybe even 2s. But you'll see when we do these, counting by 1s will work pretty much going up and down. And then once you have your frequency and your count, you just you'll see you're going to draw and fill in and color in a bar for that frequency count in that interval span. They gave you a head start. Here's our frequency. Here's the head circumference ranges. Look what they do here. Since we start at 510 and there's nothing below that, this is called like a broken line, which means it's what they call an inconsistent interval. Since we don't really use it, we're allowed to imply here that this is going to be greater than counting by tens. Because then from starting at 510, you're counting by 20s throughout. And just keep in mind, the way they have it, this is really less than 530, less than 550, even though they don't actually say it. Okay, so it's really 510 to 529, and then 530 to 549. Okay, so they did the first two for you. Well, I'm not going to flip back and forth. Let's do it together, but I need you guys to tell me what the data was between 550 and 569. What were our counts for that?
15.
Okay, so 15. They counted by twos, didn't they?
Yeah.
All right, no big deal. Halfway between 14 and 16 is your 15. And so you don't have to spend oodles of time coloring in. You can lightly shade like this. That's fine. All right, what about between 570 and 589? What was it? Yep, 9. So halfway between 8 and 10. Trace your bar down and shade. What about 590 to 609? 4. Great. 610 to 629.
2.
That's everything, right? And once again, we get to something that's a little bit more visual for us. This is kind of the purpose of why we make graphs and charts. It's a visual representation, so we could tell now, okay, we have the center of the data right around 550 to 570. Right? Most sizes are definitely going to be around the medium. So it gives us a visual representation of our data set. All right, so as we already said, the center is going to be around 550 to 570, which is the medium size. Say it again, Matt. You're right. We'll stay with what we had. Thank you. Great. How would the histogram change if you added head circumferences of 551 and 569? So 551 would fall in what range? That'd give us another medium, wouldn't it? So that would increase us up to 15. And then what about 569? Oh, I'm sorry, 16. And then what about... What? No, if you add one more for 551, it would increase our frequency to 16. Then, what about if we add a 569?
569?
Oh, you're right. There would be two more in there, wouldn't it? Okay, so it's going to give us a little bit more in the center of the data, but does it really change the center of our data? Okay, so it doesn't change our center of the data, it just gives us a little bit more higher frequency count. Peak's a little bit higher, right? What?
It says, does it change the histogram?
It changes the histogram, but it doesn't. Right. You would basically have to make it that medium hat range a frequency of 2 more. It'll have a higher peak, but the center of the data is still going to be the same. All right, there it is. All right, let's go to page 7. How much time we got? Not much, right? Let's see if we could get through C and D, and then that's going to be perfect time for the break. Recording. I kind of want you to think about this question and raise your hand and see if you can get this question right. Because the 40 head circumference values were given, you could have constructed a dot plot to display the head circumference. So you could still do a dot plot. But when you do a histogram, what information do you lose? Or, yeah, what information is lost when a histogram is used instead of a dot plot? Think about that, and then I'll call on somebody. Let me just restate it. What information are you not able to see in a histogram compared to a dot plot? Jack Choice. Yes, the exact sizes of the heads. We only have ranges of head sizes in histogram. We don't know what those exact numbers are. So let's write that down. What about the answer to this question? Suppose that there were 200 head circumference measurements in the data set. Explain why you might prefer to summarize this data set using histogram rather than a dot plot. Absolutely. It'll take way too long to plot 200 dots, and all we really care about is the ranges, because if we have to order hats ranging from extra small to extra large, all we care about is where do they fit in each hat size. All right, so there's your answer there. All right, I want to summarize the things that you've got to be mindful of when you construct your histograms, because up to this point, they gave you the intervals, and all you just did in the example was decide where the tallies go. But when you have to make your own from scratch, the hardest part of making a histogram is deciding what your interval is going to be and what you're going to count by. And even with these guidelines, it can be a little bit tricky. Things that you have to definitely be sure of is that when you decide what your interval is, it has to be consistent. So if you're going to count by tens, every bar graph, as you will, or every bar line has to be by that same interval. You can't count by tens, and then the next interval is by 20, and the next one's by 25. It has to be consistent. Ranges of 10 are usually good. When it ends on a 0, that's good, but it can also end on a 5. You can count by 5s. As you'll see, it'll still work. You kind of want to avoid counting by like odd numbers. You don't want to count by 3s or 13s. Stick with 5s and 0s whenever you can. To determine an appropriate interval, you're going to want to determine what the high and low values are, as you'll see. We'll do it. Round the low number down to the nearest multiple of 5 or 10. So if you have a value of, let's say, 13, then you're going to want your first interval to start at what? If your first value is at 13, what do you want your first interval to start at? Probably 10. Okay? Round it down. And then do the same thing with the high. If you have something that ends at 87, you want to round that last interval, if you're counting by tens, up to 90. And again, I'll show you how to do it. And I gave you the example here, but I just did it verbally with you. Once you have your high-low, and you count up all the values, you can break your total range down into each intervals. Let's just practice it. We'll do one together, and then once it's made, I'll let you make your interval. I'll let you do your bar graph. But let's do one together. Cyril wanted to get an idea of the ages of fans at minor league baseball at a minor league baseball game. He surveyed 24 people and recorded their ages below. Circle 24. First thing you need to do is, what's the high and what's the low? Ben, what's the low? Agreed. What's the high? Look carefully. Andrew. Anything higher than 52? 52 is the high. Okay, so the 6 is going to round down to what number? I agree. And 52 rounds up to, be careful, less than 55. Think about it. If you're going to start at a 5, this is where it gets tricky. The first interval, if let's say you're counting by 5s or counting by 10s, would be 5 to less than 15. This is where it gets tricky. Well, you know what? Do this. Round it to 55. You'll see what I mean in a minute, because it's really going to be, as you'll see, this. This is where it gets tricky, because you need the same amount in each interval. Now, you'll see, it'll pan out. It will pan out. It's tricky. Sometimes you got to play with it a little bit. Okay. So, now, what do you want to count by? You could count by 5s, so you get 5, 6, 7, 8, and 9, because it's 5 to less than 10. But you're going to get a lot of intervals if you do it that way. So what if I just say, let's make it a little bit easier on ourselves the first time out and count by 10s? Because you can go 5 to what if you count by 10s? Ready? 5, 6, 7, 8, because 5 is going to include 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 5 to 14, or 5 to less than 15. Get it? It's still 10 values. Okay, if that confuses you, go 5 to 14. Because look, there are still 10 values in that interval. You can't go 5 to 15, because then what is this going to start at 16? I mean, you could, but you can't have 5 to 15 and then 15 to 25, because then you don't know where to put that tally if you have a 15 right on the dot. Yes. You could. You want to do it? Let's do it. Let's do it the way Common Core does it. 5 to less than 15. In fact, I kind of want to do it that way, because that's the way they do it. And that implies, in your head, just think to yourself, oh, it's a whole number, because nobody's going to be 14.68 years old. They're all whole numbers. So think to yourself, it's really 5 to 14. Next one starts out at, okay, good, 15. 2 less than 25, which in essence is 15 to 24. Next. Oh, sorry, yes, 25. 2 less than 35. Great. Which is really 25 to 34. And next. 35 to less than. And our last one? Yep. See why it's 45 to less than 55, not 45 to 55 exactly? And guys, you could still count by 5s if you wanted to. They've made it easier on you though. Because now when we're done, how many distinct bars are you going to have? After you draw this out, how many bars are you going to have? Sure you do. Think. Each one's an interval. No. When you draw it out, how many bars will you have? Ben, help him out.
5.
Yeah, you'll have 5 bars. You'll have a bar for 5 to 15 range, a bar here, a bar here, a bar here, and a bar here. Because now all you're going to do is your tallies, and then you graph it. Okay? If you count by 5s, how many bars would you have? If your interval was counting by 5s, how many bars would you have when everything's done? Come on, think. If I count by 5s, this would make this 5 to less than 10. 10 to less than 15. So if I count by 5s, how many bars would I have when I'm done? Luke, you have 10 bars. You just twice as many bars. Okay? Okay, do your tally counts. Do your tallies. Tell me what you get. And do your tallies, do your tally counts, and then do your frequency totals. All right, Alex is going to take us through what his counts were. Go ahead, Alex. You better get this right and check your work. All right, how many of you got 12 for 5 to 14 interval? Or 5 to less than 15? All right, great, go. What'd you get? You miscounted somewhere there, Andrew. You got to check. This is what when you added everything together, Andrew. Did you get 24 as your total count? Because that's what I always verify. You have to have this frequency column has to add up to 24 when you're done. Does it add up to 24? 12 plus 5
17,
plus 3
20,
plus 2
22,
plus 22 plus
24.
2. We have a winner. 24. Good job. Give him a round of applause. Good. So recheck your counts and make any corrections that you need to. Because if your frequency counts are not correct, everything from this point forward, all of your bars and everything are all going to be wrong. This is why you have to work in pencil. Okay? All right, let's construct it. When you make these, and I'll just tell you right now, probably on Tuesday when we come back, when we're done with this, your exit ticket is going to be to construct a histogram, just like what we're doing right now. I become a stickler for the small details. Everything should have a title. All of the axes need to be labeled appropriately, and then the data has to be correct. What should be the title of our histogram? What are we trying to show? Tyler.
Ages of fans.
Sounds good to me. Ages of fans at a minor league baseball game. Always, always, always want to take care of titles and labels before we plot one single thing. What becomes the title of our vertical axis? And it's always the same when we do histograms.
Why? Wait.
No.
Oh.
Jack choice?
Frequency.
Frequency. Always, always, always when we do this. Leave a little bit of room here, though, because we do have to put the numbers in. So leave a little bit of breathing room for when we actually have to put the number values in. What's our high and what's our low for frequency numbers? Always starting at 0. That's going to be the low no matter what. What's our high? What is it? 12. 12 is our highest, right? And 2 for the lowest. So I think we have enough to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It works. What about our x-axis or our horizontal axis? What's the appropriate label? Somebody I haven't heard from yet. Intervals of what? You got it. Ages of fans. Again, leave room above the title to actually write in the intervals. Ages of fans is what will work there. Okay, now look. From here to here, because it's an inconsistent interval, we do like a little squiggly line. Because our first interval will be this block right here. Which is 5 to what?
Oh, 5.
Be careful. 5 to less than 15. And then just follow suit with the rest. I added this on here, but you don't have to. 55 and over, but there were no fans over 55, so. All right, let's get the tallies. 5 to 14, what was our count? Gotta flip back and forth. You're gonna be doing that a lot in this lesson, flipping back and forth. It's kind of a pain.
12.
Okay, so go all the way up to the top, make your 12. Got to kind of trace that line really neatly. I think when you do your exit ticket next week, I'm going to make you do it with a ruler because neatness is going to count. I should probably cheat too. Lightly shaded so it doesn't take forever to shade it. Good. That's really lightly shaded. All right, I'm going to cheat. Sorry. What's the next one?
5.
Yeah.
5.
5? Okay. 5. Watch me cheat. I'm done. I didn't shade it yet, but I'm done. I could, couldn't I? Might take longer that way though. All right, next one. What is it? 3? Okay. Check, Andrew. Something happened there. There's my 3. Then what? I'm gonna do all my boxes, then I'll shade them. 2 2s, right? 2 and 2. And that's it, right? Histogram done. And not only am I done with the shading, I'm done with my blog too.